Hello? Is this working? Okay, good. I have to check if the live stream is working. I don't know how this is going to work if I turn the sound up on my computer. Okay, good. Oh, it works. I have to check if the live stream is working. But it's delayed by like 5 seconds. Okay, if you're on the live stream, I can't take any of your questions today. I'm going to try to set up. I can't take any of your questions. So I'm going to try to set up a Teams meeting that will run in parallel with this class. And hopefully I can get the same URL for the Teams meeting each day, so you don't have to try to connect to a different meeting every time. But we'll see if I can get that to work. Okay, let's get this started. What do we do? So, okay. Okay, so welcome back, everybody. Hopefully, oops, sorry. So I assume everybody's read the COVID stuff, or you've been shown the COVID slide and protocols you need to follow. If you haven't seen it, there is a short video on the OnQ website for you to look at, or you can just read the back to school stuff for COVID. Right, basically, don't come to school if you're feeling sick, wear a mask, try to stay separated if you can. Obviously you can't because there aren't enough seats, et cetera, et cetera, et cetera. All right, so this is Introduction to Computer Science 2, so CISC124. Given that this is being offered in the fall term, I'm assuming most of you are in your second year or above. Not you? Yeah, first year, good. You've taken, so you have credit for a previous course? Perfect, so that's good. So you need to have some programming experience. The assumption is you've had Python. Right, so that's basically the way I'm going to teach the course. Right, so I'm going to show you something in Python, and then I'll show you how to do it in Java, at least at the beginning, right, to get you used to the Java language. Okay, so who am I? So I'm Dr. Burton Ma. I'm fairly new to Queens, I guess. This is my second year here, officially. I'm actually Queens alumnus, so I'm Sci 94, Comp Sci 96, and then PhD 2000 something, something, something. I don't remember anymore. Before I was here, I was at York University as research faculty, and now I'm back. Okay, my office is in Goodwin, so room 754. Office hours for now are virtual on Teams. So Friday 1 to 3, I'll be on the CISC124 Fall 21 Teams. You can just call in, and I'll be there. If you need to, you can also make an appointment if you want, if that time doesn't work for you, right? And obviously that time's not going to work for everybody. So you can make an appointment with me, just fire me an email. Whenever you fire me an email, put CISC124 in the subject line, because often I'll get emails from students and I'll have no idea what course you're talking about. So they'll say, I'm having problems with assignment 1, and I can't answer your question because I don't know which course you're in. That's my email address. There's a few other ones at Queens that work, but you can just use that one. If you need to see me in person, that's fine too. Just make an appointment. If you drop by my office Friday 1 to 3, I will be there. But I really don't want like lots of people showing up because, well, if you've ever been in the hallways of Goodwin, they're very narrow. So if there's, you know, any more than 2 or 3 students waiting, it's not going to be a good thing. Okay. Any other questions about how to contact me? If you fire me a message on Teams, the odds are I'm not going to see it, right? There's too many ways to too many ways to communicate with your instructors, and I can't monitor them all. So the best way to contact me is via email. You have 4 teaching assistants for this course, which is nice because there actually aren't that many of you. So there'll be about 20-ish students per TA, which is actually pretty nice. The TAs will also have virtual office hours. Right? So if you want to ask questions about the assignments, mostly about the assignments, or about assignment marking, you can contact your TA. At some point, I'll organize you into groups, or I'll tell you which one of your TAs is marking your work so that you know who to contact. So as soon as the contracts are settled for the TAs, I can post their contact information and get their office hours sorted out. Okay, Everything's going to be on OnQ eventually, right? Hopefully by this weekend. So as you know, the lectures are live, right? They're also live streamed. So if you want to, you can watch this at home. They're also recorded. So I've got my USB stick plugged in right now. This is all being recorded. The recording will also go up. All right, so there's lots of ways to access the lecture material. The live stream URL is there. It'll never change as far as I know, right? To access the live stream, you do need to log in with your Queen's Net ID. And yeah, so you need to log in with your Queen's Net ID. I don't believe it'll let you log in more than once, right? So the reason you need to log in with your Net ID is because the streaming service is very expensive for Queen's, right? They're only doing it this year as far as I know. And that's because of this back to school thing with COVID still kicking around. There's no built-in disadvantage, right? If you choose to stay off campus, right? So if you don't want to come to class for whatever reason, right? Whether it's COVID related or something else, right? Just stay at home, watch the live stream, or watch the recorded videos. It's fine with me, right? I'm not taking attendance. There's no in-class participation marks or things like that. Whew. Sorry, I haven't lectured in like 2 years. So, yes? Question? Oh, that's, okay. All right, course notes. So there's no textbook for this course. If you want, there are about 100 suitable textbooks out there, right? So there's tons and tons and tons of references for any introductory programming course, right? If you want, the one that's listed here really is an excellent book if you're a science/math person. It's excellent in that the number of problems it has and the amount of software it provides to you is enormous, right? So it's got really, really, really good programming questions. The problem is, this being an object-oriented programming course, it's kind of weak on that, right? So you'll reach a point in the textbook where it basically says, there's this really important thing about object-oriented programming, but we don't like it, so we're not going to tell you about it. And so that's not really suitable, right? And that's basically the last third of the course. So you can't really use that as a complete reference. But there are a bazillion other textbooks if you want. This book here, if you ever do, or if you ever plan on doing any serious Java programming, that's probably the most important book you'll ever read, okay? Oh yeah. If you follow that link, which is also on the, it's also on OnQ, it'll take you to the second edition, right? If you follow the link to the second edition and you get to the book website, if you search for the publisher, you can find the third edition. And I don't know why Queen's doesn't link to the third edition. It used to. Last year it did. This year it doesn't. But the third edition is there. You can access it with your Queen's Net ID. The Jupyter notebooks I'm going to talk about at the end of the lecture, right? So I'll get to that in a minute. Labs. Oh yeah, so there are labs. This is probably the last year that labs will be offered in this course, unless it turns out the students really like them. So they are in person in Jeffrey 155, starting next Monday, okay? So the question is, so you have 12 lab hours, 12 scheduled lab hours. So for the first, so next week and probably the next 2 weeks after that, there will be 2-hour labs. So that'll be 6 of your 12 lab hours. Basically, in the lab, I'm going to be showing you how to use the programming tools, right? So it's hard to do this in a lecture. It takes a lot of time, right? And then not all of you have your computer here, and it's not all set up, right? So in the lab, you have a computer, and I can show you how to use the programming tools that we're going to use in the course, right? So it's more of a practical thing than it is a academic thing, I guess, is the way to put it, right? There's no marks associated with the labs, right? So you don't have to come if you don't want to. But if you want to learn how to use Eclipse, well, the programming tools that we're using in the course, from someone who actually knows how to use them, please come to the lab. You're already booked into them anyway, right? The FASTA FATA, I don't know what that is, sorry. Okay, the grading scheme that was on OnQ a few days ago is incorrect. It was just copied over from last year. This is the new grading scheme. It's about 50%, I think, 36. Yeah, it's 50%-ish. Does it actually add up? Yeah, it's 50, okay. So it's half of your marks come from your assignments, right? And I'm even telling you what the assignment topics are going to be. The midterm is 15%, and the exam is in person, unfortunately, via the exam office. Right? The reason it's in person is because when you do it online, there's a lot of cheating. And it's very obvious that there's a lot of cheating. The midterm may or may not be in the lab, so I'll get to that in a second. If anybody has any questions, just stick your hand up, right? Okay, assignments. You know, you're supposed to do the assignments individually, right? You submit them on OnCue, right? So it's the same as CISC 101 and CISC 121. Now, the way this course works is 3 days after the assignment due date has passed, the assignment solutions go up, right? So you get full worked solutions for all your assignments, right? But that means I can't let anybody hand in an assignment after 3 days, right? And that includes students with accommodations, right? So if you have an academic accommodation and the 3 extra days isn't sufficient, you have to contact me for alternate arrangements, right? In order to not get hit with the late penalty. So the way the late penalty works is every day that it's late, so not every day. Once it's late, so if it's 1 minute late, you immediately lose 10% off the total assignment mark, right? So now you're getting marked out of 90%. After 24 hours and 1 minute, it's then 20%, and after, sorry, is it 24? Yeah, and after 48 hours and 1 minute, it's then another 10% off, right? And after that, so after 3 days, it's not accepted, right? On OnCue, the submission assignment closes, right? And it's not accepted. Midterm, format's not fixed, so it's going to be one of 2 things. It's either going to be in your regularly scheduled lab, right? So whatever lab session you're signed up for, you're going to go to your lab in person. You're going to sit down at a computer. You're going to work on some midterm questions, right? So it'll be a 2-hour midterm. Yes?
Do you get code or window, or is it like only code?
Well, that's the thing. So if it's in the lab, you get to code it, right? So if in the lab, you get Eclipse. You have access to the course notes, et cetera, et cetera, et cetera, right? I don't think there's any locked down test mode in our lab. So you have access to whatever resources you need to do the midterm, with the exception of you're not talking to anybody, right? So you're not using email or messaging of some kind, right? So that's one. So that's if it's, that's the way I want it to work. I'm not sure we can make this work. 2, in the lab, oh, sorry. That was 2, sorry. Number 1, it'll be online on OnCue during your regularly scheduled lab, right? So in that case, it will be online. Again, it is open book, right? So you have access to your notes and whatever else you want. It'll be on OnCue, so the same as you did last year if you were here. And that has, but it's not proctored, right? So I'm not using any proctoring software here. Right, so that'll be your midterm format. It's going to be one of those 2. I want it to be in the lab. I'm not 100% sure it's going to work, but we'll try to make it work. That's also another reason to come to the lab, at least once or twice, right? Because the lab computers are not going to be set up the same as your home computer, right? It could be if it's in Linux mode, it's a totally different operating system than you're used to, right? You should be able to do it in Windows, but if you're a Mac user, that doesn't help you. Exams in person, closed book. Right? Because it's closed book, though, that changes the types of questions that I ask you, right? So there's none of this minutia stuff, right? None of this very, 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 very intricate, detailed sort of thing, like what is the definition of blah, 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 or something like that, right? It's a different type of question that you get asked in a closed book exam, right? Rather than something you can just look up. Right? Okay, any questions so far? Anybody? Anybody? Okay. Just out of curiosity, how many of you are actually, well, you don't have to answer this question. How many of you are actually planning on coming to the in-person lecture? So most of you? Okay, good. Does that include the 8:30 lecture on Friday? Yeah, okay. So, yeah, so I actually didn't know how this would work. So I'm fully expecting 8:30 Fridays to have 5 people here, right? Because you can just stay at home and roll out of bed, or, not roll out of bed, or, walk home from wherever it was you stayed the previous night and look at your lecture. Okay, here we go. So what is this course about? It's Computer Science 2, so it's your second course in the computing science major, right? So if you read the calendar description, it tells you it's an introduction to object-oriented design, architecture, and programming, blah, 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 right? You can read this on your own time, right? What that's basically trying to tell you is that it's object-oriented programming, right? And the language that we happen to be using is Java, but really it's an object-oriented programming course. Well, really it's both, because you can't really teach them separately. Sorry, if you're going to use Java, you have to teach Java, right? There's no way around it. Okay, so I forgot to put something here. If you're a computing science major, there is a requirement on this course if you wish to take a second-year computing science course, right? So you need to get a C- in this course to take a second-year course or any other higher-level course in our department. Back in the day, so when I was a young man, a grade of C is average. Right? So hitting C- is not a sure thing, right? So you can't take for granted that you're going to get a C- in this course, right? The vast majority of students do. But there are students, some very good, who for whatever reason just don't manage it. If that's the case, you have to retake this course, unfortunately. You have lots of options for retaking the course, right? So you can take it in the winter, and you can also always take it in the summer. But you don't want to have to retake this course if you can avoid it. Okay, so what is object-oriented programming? So it's one of the most widely used what are called programming paradigms. If you go on to second-year computer science, you may end up in the course CISC124, which is actually called programming paradigms. So in that course, you actually learn 4 or more different programming languages, right? Representing 4 or more different programming paradigms, right? So what's a programming paradigm? Well, it's a particular way of programming, right? So structured programming or procedural programming is what you learned in CISC121, okay? So in CISC121, you did things like make variables, right? You did things like write loops, write if statements, write functions, right? Depending on who taught you, you may have written a few classes at the very end of the course, right? So ignore the class stuff for now, right? That's what's called structured programming, right? So control flow is defined by loops, conditionals, and function calls, right? And you can write a lot of software just using structured programming, right? So for example, the entire Linux operating system is all written in C, which is all structured programming, right? And there's a ton of code kicking around that's written in this form. So there's a completely different way of doing things called object-oriented programming. It's actually not completely different. It's on a scale, right? So in object-oriented programming, your program is made up of things called objects, right? These objects have state. All that means is they carry information, right? So for example, you might have a point object that has an x and a y coordinate, right? You have lots of them, so you can have lots of different points, right? And all of these objects, they have this thing called behavior or methods, right? In other words, you can call a method on the object and the object can do something, right? So for a point, you might tell a point to move, right? And you tell it how much to move by, and the point state changes, right? You might do things like ask the point for its x and y coordinates and things like that, right? So in object-oriented programming, you always need an object to call a method on, right? And you've got a bunch of these objects in your program, and they all interact with one another, right? In the object-oriented lingo, we say they interact with one another by passing messages. All that means is they call methods, right? So you have a point that might call a method on some other object. You've got an object that might call a method on some point, and so on and so on. Sorry, and so on and so on and so on. The big difference between these two, right, is how the program is structured, right? So in object-oriented programming, all the information, well, not all of it, most of the information lives in objects, right? In a structured program, right, your information lives somewhere else, right? It's normally a global variable or something like that somewhere, right? Similarly, you always have objects calling methods on other objects, right? Whereas in structured programming, you can just call a function without needing an object. In CISC121, you actually did do a little bit of this object-oriented programming, or you used it whether you knew it or not. Right? So for example, if you used a list at all in CISC121, and you called its append or extend method, extend, you're actually using an object. Right? In Python, everything's an object, right? Whether they told you that or not. It's just that the way you were taught to use the Python language was not in the object-oriented way. There's many, many, many other programming paradigms, right? Like literally dozens, right? Okay, so what is Java? So Java is general purpose, cross-platform, object-oriented programming language. General purpose means it's not designed for any one specific thing, right? So you can use it in a wide range of problems and domains. Cross-platform means it's not dependent on any type of computer architecture, right? You can run it on your desktop, you can run it on your smartphone, you can run it on tiny little embedded devices, right? So most routers or most of your internet modems are running Linux inside of them. Sorry, not most. I'm getting confused with CISC220. You can run Java on your modem. On many modems or routers will use Java internally. Oh, a lot of cars have Java in them in some form. Right. So Tesla uses it in their cars. Mercedes-Benz, Toyota, and a few others all have Java of some form somewhere in their car. Okay. Now you have to. When you look at the Java language, so right now you're not going to appreciate this, right? But when you actually look at how the Java language works, you can see that it's a product of its time, right? So it was created during the early 1990s, which is before most of you were born, right? And it was to address the issues in another language, right? Another two, basically, right? So the two dominant languages at the time were C and C++. Which you also learn in your computing degree, right? So in CISC220, you learn C. One of the third-year courses, you learn C++, right? So the primary goals when it was designed is that it would be a simple, object-oriented, and familiar, right? For a programming language, Java is pretty simple, right? Especially if you compare it to something like C++, right? From a student perspective, it may not be that simple, right? But really, from a higher level perspective, it is a pretty simple language. It was designed to be robust and secure. So at the time that it came out, C and C++ were notorious for having lots and lots of bugs related to security, right? And that's just that was a product of the design of their languages. Architecture neutral and portable, right? So that means you can run a Java program, you can write a Java program once, and the goal was it would run on any device, right? That was the goal. It didn't quite pan out that way, but that was the goal, right? That's very different than C, right? You can write a C program on one computer, take it to a different architecture, and suddenly your program doesn't behave the same way anymore, right? And that really infuriating if you're trying to write software for lots of people, right? Spend all this time writing your program and getting working, take it to a different computer and suddenly it stops, right? So that's not good. So it was designed to be architecture neutral. Execute with high performance. When Java came out, that wasn't so true, right? Nowadays, Java's pretty good, right? You're still not going to use Java in anything that needs really, really, really high performance, right? But right now, it's pretty good. Interpreted, threaded, and dynamic. So those aren't terribly important for our purposes, but interpreted means, so interpreted is related to this number 3, right? So you know Python's an interpreted language, right? You type something in, press enter, and something magically happens, right? The magic is that there's an interpreter that interprets what you typed in. Java is similar, but what it's interpreting is not what you typed in, it's something else, right? But because it's interpreted, all you have to do to run a Java program is write an interpreter that happens to work on the computer that you're targeting, right? Once you have that interpreter going, you're good to go. You can take any Java program, run it on the interpreter, right? So that's so Java and Python share that. Threaded means that you can run many different processes at the same time. Right? And you'll learn more about that in your operating systems course. Right? For now, it's not important. I forget what they meant by dynamic. That's a very not specific word. So I'll just leave that for now. OK, so where is it used? So Java basically is one of the two main languages used in enterprise software. So enterprise software is software that's not written for individual people, right? So like PowerPoint, right? It's software that's meant to be used by big organizations, right? So Java is one of the dominant languages there. On the server, right? So on the server side of anything that's networked, there's a good chance that there's Java of some form running. If you've heard the term big data, Java is very popular in big data too, right? So that's big data is where you have lots and lots of data moving around over a network. You need to store it somewhere. You need to be able to access it over a network. So Java is very popular in that domain as well. Embedded devices, that's basically anything small, right? Normally doesn't have a screen, but there's a computer in there doing something. Right? So Java will run on lots of embedded devices. It'll run, so Java is Android. So Android is basically is written in Java, right? Or requires Java, uses Java. Some scientific applications, so this is a kind of an interesting one. It's used a lot at NASA, of all places. The two rocket companies, what are they called? Blue Origin and, yes, also use Java, believe it or not. It's not, I shouldn't have put the last one there, right? It's not really used in video games. The only one you've probably heard of is Minecraft. The original Minecraft was written in Java. Today, the only semi-popular game that I can think of that's written in Java is a game called Slay the Spire, which is kind of an indie game. If you hit that link, it was the 25th anniversary of Java recently. So the people at Oracle, who are now the keepers of Java, they wrote a little blog post about the 25 greatest Java apps ever written. It's kind of surprising. So Java was on the rover that went to Mars, right? So that's one of the 25 greatest apps that were ever written. So it's actually used in a lot of places. OK. So the obvious question to ask, given that you came out of CISC121, is why are we not doing Python, right? Because we spent all this time learning Python, right? Python also has object-oriented, it can also be used in an object-oriented way, right? So why don't we just stick with Python, right? So the answer is, it's good for you to learn lots of different languages, right? So the more programming languages you're exposed to, right, the more ways you see of doing things, right? And that makes you a better programmer. The real reason, though, is that it's easier to transition to C and C++ from Java. So when you see the language, you'll see it looks a little bit different than Python. But if you're a C programmer, you'll say, hey, this looks a lot like C, right? And you need C and C++ to progress in your computing science degree, right? So the next course that many of you will take is CISC220. CISC220 is C and is half of it is C, right? So that's the reason we're using it here. Also, I mean, it's kind of used everywhere, right? So when you graduate and you're out looking for a job, being able to say that you can program in Java is not a bad thing. OK, using Java in this course. So if you've looked at the on-cue at all, you'll see that there's lots of instructions on how to install the software for this course. If you're in Mac, right? And so if you're in Mac, the original instructions I posted, unfortunately, are wrong. But I fixed it yesterday or the day before. Right? So if you're in Mac and you have to do things twice, I'm sorry. If you're in Mac, you have to install the JDK. Right? So you should install the Oracle JDK, because if you try to install the OpenJDK, it may not work for some reason that I have yet to discover. Right? But if you use the Oracle JDK, everything works seamlessly. So that's if you're in Mac. If you're in Windows, apparently you don't need to install the JDK. If you install the new version of Eclipse, Eclipse internally has its own Java runtime. which means you don't actually require the JDK. I recommend you install the JDK anyway. It's not hard to do. So you need the Eclipse IDE, so the Integrated Development Environment. I'll get to you in a second. Right? Other IDEs are fine. Right? So if you're someone who's been programming in Visual Code or IntelliJ or something like that, I don't care. But I can't support them. Right? There's too many of them out there. Right? So as long as you can get your code from an Eclipse project into your IDE, use whatever you want. Yes?
I was going to ask about IntelliJ.
Yeah. So IntelliJ, I mean, a lot of people will tell you IntelliJ is much better than Eclipse. A lot of people will tell you Eclipse is much better than IntelliJ. I'm of the opinion that it doesn't matter, right? So the problem is I can't support every possible IDE that's out there. Yeah?
All the lab stuff you said will be down in
Yeah, so if you're in the lab, I'm showing you how to use Eclipse. Yeah. But if you've used any other IDE, any other professional grade IDE, right? You should be able to use Eclipse, right? If you use something like BlueJ in high school, you probably can't use Eclipse just by using BlueJ, right? So Eclipse is a professional quality tool, which means it has a professional quality learning curve. And it would suck if you didn't get a C- just because you couldn't use Eclipse, right? Okay, Jupyter Notebooks. This is less easy to do. For many of you, if you just follow the instructions online on you, so if you follow them carefully, right, everything will go fine, right? It'll install, it'll be no problem. For some of you, the installation's not going to go fine. Right? So for example, yesterday, I took a Teams call helping somebody get their installation done. So their username on their computer has a space in it, right? First name, space, last name. It's on Windows. It turns out Jupyter and BeakerX won't install properly if your username has a space in it, right? And there's lots of other things you can run into as well, right? And it's not always easy to debug, right? So Jupyter is this big open source piece of software that uses lots and lots and lots of other open sources, lots of other pieces of open source software, right? And so installing all of this, anything can go wrong, right? So you cross your fingers and hope it goes okay, right? For the vast majority of you, it'll be no problem, right? But for some of you, you will have problems. You have to contact me. I'll try to help you. What else? Okay, so be wary of the installation. It's not, you may run into issues there, right? Don't be surprised. New this year, actually new this summer, and I just found out about it now. So the notebooks have Python code in them, and they have Java code in them. Python code doesn't run properly. I'll show you in a second. And the last one, this is mostly so this is totally for students who, on their computer, your computer is not set to English, right? So the character set that you're using isn't English, right? Mostly this is happening with the students from Asia. Right? So a lot of the students from Asia are using Chinese or something else, right? Or one of the many different Chinese character sets, right? Jupyter doesn't work properly. It's not Jupyter. Python, the Java kernels don't work properly. The notebook shows up, you can't run the Java code, right? So there's a solution for all of that. So you don't have to install the notebooks if you don't want to, but I recommend you do, okay? So if you don't want to, there is, yes, I'm still here. Okay, so there is that link there that says online. Or if you know how to use GitHub, or if you've used GitHub before, you can just go to my GitHub page and you'll see the link there as well. You don't have to copy down this link, it's on you, right? Oh, hey, oh yeah, my laptop's not connected. There's an online version of the notebooks, right? That behave exactly like the notebook on your desktop, right? So you can always use the online version of the notebook. Okay. So I'll show you the Jupyter notebooks. Why is the, can you guys read, you guys can't read that at all, right? Sorry, let me just adjust my font size here. So when you, when you get Jupyter installed, or if you're using it online, and you open up the table of contents page, you'll find all of the notes for the course. There's a lot of them, right? So there's a ton of notes. The way the notebooks work, so they run in your browser, right? So you do need a web browser that's working. Now the cool thing about the notebooks is the notebooks can contain information in the form of just text, right? But the notebooks can also contain code. Boop, boop. So there. So that thing in gray, anytime you see a box in gray, that's code. You can run it straight in the notebook, right? So this is going to be Python running inside Jupyter, which is running inside a web browser, right? Last year, or even this summer, sorry, that would work, right? I'm pretty sure it's not going to work for you this year. So if I run that, yeah, you get an exception, right? So anything in Python, unfortunately, you can't run, which isn't the end of the world. It's not great, but it's not the end of the world because it's not a Python course, right? And the Python samples are small enough that you can understand them without having to run them. If you run them online, weirdly enough, they work. If you install Jupyter on your computer, Jupyter and BeakerX on your computer, they don't work. Right? Something in the whole Jupyter distribution has changed since the winter, which has caused this to break. Okay, the Java cells, though, they all work. Right? So here, there's a little Java program. Right? You can see immediately that Java, this is just to print out hello world, right? You have to write a lot more Java, unfortunately, than you do in Python, right, to print out hello world, right? The notebooks explains everything that's going on here, right? I'm not going to explain what's happening here, but you can run this, right? And you get some output here. Don't worry what that means. All that means right now is that the Java compiler has managed to compile that cell successfully. I can run that by clicking there, and you can see that it spits out hello world, right? And for a student, this is a really powerful way to learn, because you have total control over the notebook, right? You can go into that cell and change whatever you want, right? So I can change this to let us wrap this up, right? And I can run that again, and I can run that again, and it changes, right? So the notebooks are designed not for you just to read them, right? They're designed for you to actually interact with them, right? You should go in, mess around with the code. You can't break anything, right? Go in, change stuff, run it, see what happens. The result appears instantaneously, right? Which isn't what happens if you're working in an IDE, right? In an IDE, you have to save stuff, you have to recompile it, you have to run it. Right here, you just click on the cell, run it, and away it goes, right? You can see the result instantaneously. And one more thing before we go. The other nice thing about Jupyter is that you don't need a complete Java program, right? So every Java program has a class. If you want to run it, it has to have a main method, right? Which means you have to type in a whole bunch of stuff just to see if you can print something, or to see if x plus y equals z, or something like that. That's not true in the notebooks, right? So in the notebook, I can have an incomplete Java program, right? So that's not a complete Java program. If you fed that into Eclipse, Eclipse would say, hey, I don't know what to do with this, right? But in Jupyter, you can just run it. You can run it, there you go. And something happens, right? If you watch, or if you have watched, or if you do watch the videos that are online on OnQ, I show you how you can edit the notebook, right? So you can add your own notes in the notebook, right? You can add your own code in the notebook. You can add new notebooks, et cetera, et cetera, et cetera, right? So sometime this week, make sure you get your Eclipse programming environment set up. Try to install Jupyter and BeakerX, and try to access the notes. All right? And that's all for today.